Hi everyone, I'm Maria, and today I will be speaking about the DICOM protocol and how it's related to medical imaging applications and the results of my investigation. I'm a student at Tomsk State University. Currently I'm graduating it with the IT security specialty, and I work as a developer at Bizone, and I'm a member of a research group in AISec. The AISec team is a community-driven research project focusing on implementation, security of artificial intelligence and machine learning technologies. You can find some URLs on this slide to the project I'm going to talk about. That's number one. And the second one is the repository, where you can find all of the information about our team and some other pieces of research and articles. Okay, why medical imaging? It's possible that you might have heard that medical imaging is one of the popular trends these days, where the neuron works are used for the classification of medical studies. And these medical studies are posted in the DICOM format. So what's DICOM? Digital Imaging and Communication in Medicine. This is a protocol with two parts. First of all, is for exchanging files between various components. The second part of the protocol describes the DICOM format as it is on the disk. On the slide, you can see an example of the DICOM file. You can see that each DICOM file contains the main information about the patient, like the patient's name, and the complete investigation. DICOM may be interesting about medical imaging. So let's imagine that we have some kind of a neuron network working with the lungs images, detecting whether this person is ill or not. And there may be an attacker that would like to poison this network. Knowing the vulnerabilities in the DICOM protocol, he would send the wrong files on purpose, and after a while, this network will start giving out the wrong data. It will start saying that the person who is suffering from COVID, that he is not infectious and contagious, and the contagious person will walk the streets infecting other people. One of the products in medical imaging is NVIDIA Clara. NVIDIA Clara provides a set of tools to build and manage and deploy intelligent imaging. That's for neuron networks. NVIDIA Clara has a component which actually works with the DICOM file entitled DICOM Reader. And DICOM Reader is a container, Docker container. If you take a look inside, you can find the Python source files, and you can find that NVIDIA Clara actually uses simple ITK library to work with DICOM files. I've been using Fuzzing as one of the methods of finding the vulnerabilities there, and after a while, FL has found some buffer overflow. A funny story broke out with a vendor when I contacted the vendor, and I said that this file is triggering the overflow. Please check out the source of the problem, and possibly you need to fix it. The vendor has been studying my file for a very long time, waiting for too long, and then he would say, it's my wrong file, and why did you send me? Here's the right file, which is the valid one. And he said that there is nothing to fix here. Luckily, this story ended up quite well, and that bug had been fixed. There is yet another bug I'd found by my very precise and close look, is the classic buffer overflow. Some memory is dedicated, and there in this data is put and copied from the entry file. To trigger that, you need to create a DICOM file with the name of the patient, which is more than 512, and this file will trigger the buffer overflow. Orthanc. Orthanc is the DICOM Explorer. NVIDIA recommends it for the management of the entry data in your network. Orthanc is convenient. It has some web shell, and to work with it, you just only need a browser, and that's it. Orthanc itself is quite popular in medicine, and it's used in some hospitals. Mostly it's used in hospitals and some universities. So here's a GIF image on the slide with the list of those who have used it, and I've taken this GIF from an authorized website. Orthanc is open for the community of developers, and it provides the contact with the developers so they can write upliners for it. Let's just speak about it a little bit later, and now a bit of a statistics of the use of Orthanc on the internet. As far as you can see, it's not in Russia, but it's popular in Europe and America. Let's just take it the API. It's the method of the methods of accessible. There are methods that work with the DICOM protocol, and there are some methods working with the server, like reset and shutdown, and a very attractive method. It's called execute script. What does this method do? Orthanc is the project with the open source code. Seems like this method is doing what it explains. It's just waiting for the scripts and runs them without any validation and without any limitations. For example, here is the request, and inside it there is a command on creating a file on the folder, and the folder is successfully created after this request. It's kind of unpleasant if you download the binaries from the official website and you launch them by default without any authentication. You are quite ready to run these scripts. It's kind of unpleasant, but if you use Orthanc from the official Docker container, then authentication is engaged by default, and you don't need to tune up anything. Only those can run the scripts that have been authorized to do that in Orthanc, which is good. But it does not mean that this authentication is not vulnerable to CSRF attack. Here is the example of the code which this page should contain, so that the Orthanc user can actually connect to it later, and there the request would go to the Orthanc server, and the code will run there on the server. Immediately I responded to the vendor and let them know that this is kind of vulnerable to CSRF attacks. Please fix it, in other words. And the developer replied that in actual fact, Orthanc is a microservice, and it's designed to be used within a secured environment, which you should maybe create yourself. And the Orthanc just warns you about CSRF, and they are not going to take any steps to fix that. All right. So if you take a look at the Orthanc specification, it reminds us about, it warns us on CSRF attacks, but I got a little bit suspicious, and I decided to check how polite the vendor has been with me, and I checked that in Google Cache, and a few days prior to my report, there's no CSRF warnings were there. All right, then. And then I think we should go to the next vendor, DCMTK DICOM Toolkit, which is a set of tools to convert DICOM files. And this DICOM kit includes the DICOM server. What's interesting here is that this vendor has actually started the development when the development of the protocol itself actually started. And this implementation of a protocol is standard for other vendors. For example, Simple MTK, CMTK is the prototype. They think that this should work just like with DCMTK. DCMTK recommended when you create your own pipelines for training your network to work with medical images, and DICOM server is used here from this particular toolkit. To find the vulnerabilities with DCMTK, I've used Fuzzing with, and this Fuzzing has found a few DOSes in different utilities. XML, there was this idea just to try the simplest payload, XSE payload, just to check the vulnerability for XXE. We create an entity and we point out this entity in the patient name, for example. So after the conversion, the converted file will contain etc password. There was also this interesting vendor story when I said that your parser is has got XXE injection, please check this out. And to which the vendor has replied, correct me if I'm wrong, but maybe there is no vulnerability at all because this payload doesn't work on their machine. So I decided to find out why it was like that. And let's just take a look at the OWASP page. They use this libxml2 library to read the XML files, and that's what OWASP speaks about it in the XXE injection context. It says that you should not be using these two options and XML parse DDD load. And they say that starting from version 2.9, XXE has been disabled by default. And they are also warning us on being very careful on using these functions from this list. DCMTK has not used any functions from this list, and none of the options have been sent for parsing. What was the problem? After talking to a vendor, it turned out that we were using different libxml versions. And the final fix of the bug looked like that. The vendor just changed the entry value from 1 to 0. So what does this function responsible for? What is it responsible for? It actually changes some global variable. Then this global variable is used to initialize the XML parser. On the slide, here we have the source from what the vendor had been using. It is higher than 2.9, and it should have been disabled by default, and this is what happened in my version. It worked in my case, but not with the vendor, and this is happened what relates to my version. A dangerous option was added that made XXE injection possible. I think it's neither OWASP that has warned us about being too careful about this function. And moreover, if we take a look at the documentation, libxml2, there's been no warning, no footnote warning us about that if you are using this option, please be careful. What this function does, it enables the substitution. It uses the entities in your file and external entities. We wanted to find the same snippet codes. What if we find a similar problem, just like CMTK? But this has not happened. We found out the Postgres source, and we could see easily how this function was used. They have the same initialization as CMTK. They substitute entities default. But before that, they put it in the situation when the parser would like to download entities from outside. Those entities that you try to add from outside does not initiate injections here. It's a long story, but anyway, it means that any developer who starts working with the library libxml2 will ultimately, possibly, I would say, face with the same problem. And they would have to have some sacred knowledge, and they will not have to take a look at the documentation or OWASP. They will have to find some use cases from large vendors, which I don't think is good. I think here we are done with XML, and right now I think we should be going back to DICOM. It's the same parser. It has the same functions as the insert of the data into the resulting file of DICOM from another file. It uses the same principle, like SSE injection. So finally, the DICOM file will contain etc svd file, but here the vendor replied that none of the parameters and none of the keys are going to be added there, because it was just intended like that, and they are not supposed to do anything about it. Okay, we ended up with DICOM format here, and I think we'll just need to think about the protocol which describes the network. DICOM describes the interconnection between the two devices. There would be two devices: the device that does the study, does the examination, I would say, and the actual database of DICOM. Or DICOM server. Another example of the use of this protocol is when the doctor would like to get this research from the remote DICOM server. On this slide, you can see the example of the main commands of the DICOM protocol. The first command called echo, and it's used for the test connection between the two devices. The find command is used to find the selection from the accessible studies from the remote server, and the move command to get to these files and to store it is to store these files on the remote server. Unfortunately, in the network, the whole majority of DICOM servers are tuned in a way that they allow to establish the connection to any user in the network. So all you need to know here is to know the host and the port. And you also need to know the application entity title. Application entity title is access control when DICOM server is used by two different systems, but they have got the same DICOM server, and the DICOM server can have a collection of for different systems, and it's also a method of identifying the client, those who would like to get access to DICOM studies. But seems like a large number of servers are tuned the way that this is a default setting. You can take all of the titles from possible vendors and make brute this with your dictionary, brute this title. And the first command allows us to get the list of all of the possible studies. And with the second command, which study is required, we just show the name of the patient, and we get it with the get command, and we get the study. And that is it. We have some usage statistics of DICOM servers all across the globe. It's made with the grinder, and there's an interesting fact. When the group made the scanning of the DICOM servers in 2019, it was approximately 1,000 servers. But when in 2020 I asked to make the rescan of DICOM servers on the internet, it turned out that there was more than 2,700 servers, which proves that the use of the DICOM protocol is increasing, but seems like not too many people are addressing the security issues in the implementation of its protocol. I also did some fuzzing of the network realization of this DICOM protocol. And it will give you the API for you to do your own things. To expand this, you need to add two functions, parse input packets, and the second thing, to retrieve status code from servers response, and it will be used for further mutations. By request, I did the official repository of AFL.NET. It was merged, and you can also use AFL.NET for fuzzing this DICOM protocol. How did I add this file? Here is an example of approximate structure of the packet. The DICOM protocol is kind of a complex one. I don't really know how it works completely, but the approximate structure of the packet looks like this. Each packet has a PDU type, which I use as a status code, and each packet has got PDU length, which can be used for parsing the boundaries of the packet. FLNet found a few DOSes which have so far been fixed, and I would like to speak about the use of FLNet. The FL directed to socket found the same problems a little bit faster than FLNet did. Probably you have a little bit different experience of the use of the same fuzzer. And in the end of my presentation, I would like to make a summary. And in the end, I would like to say that the DICOM protocol, it's used for medical imaging. It's one of the machine learning trends. But on its own, it operates with patients' personal data. And the question of security is still open. And some by default configs of the DICOM servers allows almost anyone to get access to this data. And the DICOM realizations have basic vulnerabilities like XXE, CSRF with remote code execution. And they've got some dubious remote code executions of a random code and the read of the random file from your system. And there are plenty of DOSes. There are plenty of DOSes from DCMTK. Maybe they not have been DOSes, but I just couldn't really follow them through to the end. But basically, this is it. And thank you for listening. You can contact me by Telegram, and I expect your questions later. Thank you very much for joining us here.